Let m of x equal 2x cubed minus 4x squared minus 16x, and n of x equal x squared minus 3x minus 40. The function r is defined as r of x is equal to n of x divided by m of x. Determine the domain of r. So the domain is every x value or every input value that we can use for a function. So for functions that use our typical algebraic forms, we would assume by default the domain is all real numbers, negative infinity to positive infinity. Where we start to restrict these values is where we break math, and in this case here, it would be where we divide by 0. So we really don't care about n of x, we only care about where m of x is equal to 0. So we're going to set m of x, which is 2x cubed minus 4x squared minus 16x, not equal to 0. And we'll solve it. So the first thing I notice is that we have 3 terms, and every single term is even, and every single term has an x. So let's factor out a 2x. Doing this, we are left with x squared for our first term, negative 2x for our second term, and negative 8 for our third, keeping in mind that this is not equal to 0. Now we're left with a quadratic inside these parentheses. We can factor this. What multiplies to negative 8 and adds to negative 2? Well, that would be negative 4 and positive 2. Keeping in mind we still have this 2x in front. We're not equal to 0. So typically we would solve these when it's equal to 0. In doing so, we use the zero product property. Basically, if we're multiplying a string of things together, the only way to get 0 is if one or more of the parts are 0 that we're multiplying by. That's the only way to multiply to make 0. So we're going to look at each of these separate factors and see what makes them 0. For the first one, it's only 0 when x is 0. The second one here is 0 when x is 4. And the third one here is 0 when x is negative 2. So we can have all real numbers except for 0, 4, and negative 2, which means that C is the correct answer.